please find some place to sit again or make your discussions outside, please. We will continue now with Myth or Reality BIOS-based hypervisor threat by Michael Utin. Welcome.
Okay, it's nice to see you here, and this is my third, actually fourth presentation at DeepSec. And now we are going to dive in quite specific issues which are associated with information technology, virtualization, and other things which involved virtualization. So myth and reality. Why myth and reality? They intersect. Sometimes we think it's myth. Sometimes in a short or long time it becomes reality, and sometimes reality just converts to myth, and that's it. That's our real life. Our culture full of myths. First myth, maybe which I like, is myth of Achilles. It goes back to 2,000 years, and in terms of information technology, it means is try to achieve ultimate protection and actually creating a single point of failure. You see it on the picture. It's now we see it's everywhere. Trying to do the best, but sometimes failing. Also, myths surround us in the form of ghosts, witches, witchcrafts, different things like that. It's entertaining and but unsuccessful. However, some people believe and claim they've seen, worked with, etc. Ufology is also like that. And information technology actually has its own myth, which is named IT management. We will see how why it's myth in our case number 3. If IT management were a reality, we wouldn't get this case, and I wouldn't discuss this matter with this audience at all. So going to where we got the ghost number 1, and which we named Russian ghost. We found it on Russian hacker site at the end of somewhere in the beginning, in the mid of 2012. It'd been posted on the site, and it had all like myth attributes. So basically, been some rumors about this post. We've seen posts and social media everywhere. And who posted, the storyteller or Russian scientist, actually claims this ghost as reality, but he never got it. So he didn't cage, he didn't have an instance of, only the trace or behavior. So our research is about 3 cases. Why 3 cases? Because first our interest started with Russian post. We thought that it's a very interesting topic, but didn't actually believe in that and tried to search around information which would be related for this kind of case. So we finally found case number 2, which actually points to US Michigan University virtual machine security. Finally, when we researched this case and correlated with the first one, we found the third one actually been published in the middle of 2013 when we been in the middle of such research. So it's again Michigan University case, but it's already about information technology inconsistency and information technology vulnerabilities. Exactly, it's about intelligent platform management interface and its core component baseboard management controller. So you see how in our diagram all those 3 cases, there are all dates, some references, some abbreviations which I explain. So that is the line of our research. Please excuse, it's going to be like approximately 40 plus slides. It's our way of presentation. We would like you, after the presentation, having almost like a paper to look through, to consider it, to maybe to communicate us your questions via email or maybe on a call. So we would like you having a paper, because any paper to prepare takes maybe 1 year, 6 months at least, okay? So we are going. Case number ancient ghost. We found it in the middle of 12th, and it contains various topics. It's not like a technical article explaining the case, and Arthur actually points out, yes, it's not a technical article, it's everything about the case. It's written in Russian and published in Russian hacker site. That's why it basically was not available to English-speaking audience, I would say, to 99% of security community. We translated the text, and it's actually available now in copies, and it was given to DeepSec. DeepSec posted some summary on its site already, and I hope the document will be available soon as well. In any case, it won't be hiding anymore. Malicious bias loaded hypervisor, that's how we name it. Why it's so? Because during the research, Russian scientists found that something interfering with his research. Exactly. It was a typical Russian computer science project. Russian scientist was going to do a sort of symmetric multiprocess system or multi-computer system for various projects. I do believe it's been for Russian government, maybe for security, maybe for defense, who knows. The project been supported by one of Russian companies, been the customer support. And during this research, he found that after he created his own hypervisor, which would support his task of distribution information between computers. So when it's been done, his hypervisor just simply didn't work. And he tried to figure out what's going on, and finally he figured out that something actually interferes with activity of his hypervisor on the same level. It's been a pretty long, as I understand from his paper, it's been pretty long way to try and error. Finally, he debugged, and he figured out that when he uploads code from Intel official site in motherboards, then motherboards would work. I need to just return a bit back, because it's like the project actually started with motherboards labeled made in Canada. So his project actually worked with those motherboards. The problem actually started appearing when he moved his project on so-named production boards, which been labeled made in China, and that's where the problem actually happened. So he tried to debug, and when he uploaded the code from Intel site, official Intel site, to China-made motherboards, they started behaving in the same ways as assembled in Canada. So basically, his project worked. So his opinion was that Chinese boards had two software systems working simultaneously on the same hardware virtualization level, which does not allow sharing of resources. That was the problem. It was a really significant finding because he identified that there is a malicious hypervisor embedded in BIOS, which utilizes hardware virtualization Intel CPU capability. That was the point where we decided just to do some sort of investigation and seeing that, yes, it's possible that such board could be manufactured in China. But what we also didn't find, you see, yeah, those dates, but also what we found is that actually boards labeled assembled in Canada actually without they've been assembled in Canada, because there is no manufacturing assembly facility in Canada of Intel company. So for him, it was an, like scientific interest and like investigative interest. He wanted to know where actually this hypervisor exists, in which part of BIOS, because traditionally there are three actually BIOSes on Intel-made boards, and so he wanted to figure out which one. That is finally, his search ended up in he identified that the malicious hypervisor is embedded in the memory of baseboard management controller. As he doesn't explain how he did it, but I understand that he somehow managed to split Intel file for updating BIOS into 3 pieces. It actually consists of 3 pieces. So it's possible to identify which piece and each time actually gets in the BIOS. So that is a block diagram of IPMI, and the core component is BMC. You see in the diagram, I believe you know actually BMC and IPMI control everything in computer system, from access to its memory, from shutdown operations, reboot operations, basically everything. So what relates to IPM is IPM is a core platform now. Okay, that's very important, and that's it. We face this reality. IPMI exists, and server use it, and we almost have to use it. BMC is core controller. There are 3 flash memory devices and which support BMC and others. BMC BIOS also is encrypted and decrypted internally before execution. BMC is connected to the system bus and thus can access to everywhere. So this is, I would say, typical IT solution which provides users of service with powerful, useful, but as we understand, it's really vulnerable system. So those are like some excerpts from the article, and we actually already discussed it. So when he found it and actually experimented with, he wanted to show, the scientist wanted to show his case and discuss his case with his management and with some Russian authorities, how maybe any security person would do it in this country or in the United States, whenever. So just a second. Oh, missing. So when he informed management of Craftsway company, he got the response that just stop talking about it, it hurts business. Finally, his research ended up in that motherboards from new shipment didn't have his hyperdrive at all. So he continuously improved his software, but also during his research, he's seen that boards labeled assembled in China also kind of been improving its malicious hypervisor. And finally, as we see here, it's been up to the point where two virtual management systems existed in one computer and didn't almost interfere. So next his attempt was to figure out how this hypervisor could be identified, because at some point his first method of identification of the malicious hypervisor actually failed. It failed because Intel improved hardware virtualization support, and it actually moved to new stage. He modified his software, but his software, even modified, didn't work on China-made boards. So they worked on boards labeled assembled in Canada, but didn't in China. So, and basically up to, he was not able to get it back, even using upload of the BIOS code from Intel side. So his opinion was that developers of malicious hypervisor actually frozen the code, so it's done. They consider the development is done, and now basically in production. So he needed some sort of different method how to identify, and he decided to catch on execution of various commands. So he wrote a program, and he ran on system which had on boards from Canada, and that is the result of that. And what it says is this original screenshot from his article says those are commands, the left column. In the middle, there's execution time. On the right, it says hypervisor is not found. The second, he ran on boards assembled in China, same software, and he found out that there is a real difference in execution time. So same commands, really different time, which is actually 60 times more. And the right column says hypervisor found. Here we just have some concerns. We didn't go so deep in this research to identify whether his measurements are correct or not, but we have some doubts that hardware virtualization could increase execution of some commands 60 times. So first, his attempt to discuss case with his management at Kraftwerk company, his customer, failed. Then actually he went to Intel representative in Russia, no response. Now, next he managed to talk to so-named as now it's Russian FSB, former KGB, Center for Information Protection. No understanding. Next, he went to second meeting, no understanding, a case dismissed. And finally, he hit the wall. Nobody was actually interested in the case. Who cares? Last his attempt was to convince one big company. It's a Russian Gazprom company, which deals with gas and oil production. It's a state enterprise. So he didn't understand. He actually presented the case, and he tried to make a demo which actually kills the computer. He wrote a program which is being used in virtualization, and he showed like malicious hypervisor can actually kill the computer by complete wiping out the BIOS. But his case was also kind of dismissed. People at this company said like, we depend on state standards, and basically it's not our real concern. Conclusion. The most disturbing, the post describes unique experience of identifying malicious hypervisor which is loaded before OS boot up. Yeah. So that is the exact point of the research. So it's not clear how BMC loads, but definitely malicious hypervisor being loaded from BMC into computer and actually below the OS. How we believe in that? Well, based on the article, technical components and everything, we believe it's 90% true. Okay, so it means that we actually believe it's been done, and our further research actually supports that. But we reserve 10% as benefit of doubt. Malicious hypervisor is embedded in BMC BIOS, as we discussed. We've seen development and improvement of MBLH. It's a malicious BIOS loaded hypervisor up to the level where it cannot be identified. Basically, as in his experiments, he was able to identify only switching boards. That's it, nothing else. Experiments with commands execution time to identify the existence of MBLH are important, but lacking details. That's why we actually would like to clarify this case, and we are not satisfied with his measurements. We are not sure about them. Maybe they're right, maybe wrong. We don't know. While the scientist doesn't actually finger points to saying like, yes, China made, and that's China government hand, whatever. He doesn't do it, but he continuously says boards assembled in China, boards assembled in China. But we believe that assembled in China doesn't mean anything here. It's just a label. It's the same as assembled in Canada label, which we didn't find any Intel manufacturing facility in Canada which could be which could do it. But details of the case, MBLA might be even developed by a company he worked for, Kratzwey or FSB, who knows? Because it's just open question, how it's been done and where it could be done. So now we are moving to our second case, the case which we researched based on a Michigan University paper. This research been supported a few prominent sponsors like National Science Foundation, U.S. National Scientific Science Foundation, Intel Corporation, Microsoft, and also an entity like ARDA. So we identified that actually ARDA is equal to currently existing Defense Advanced Research Project Agency, which is dependent of the defense agency and supports various projects of defense interest. So this case, this project been done around 2005, 2006, actually 1 or 2 years before Russian case. Scientists been involved in his hunt for malicious hypervisor. So the purpose of how the name VMware Research. We evaluated a new type of malicious software which that gains a qualitative new control over system. So basically, what they tried to do, the point of research was to create a malicious software which uses virtualization and which is like ultimate malicious software which cannot be almost cannot be identified and almost there is no defense against. So they tried to imitate hackers, but I really doubt that hacker community ever would come with this kind of project. This approach, the approach which they implement is different from which we discussed in case 1, because what they did actually was not embedded in BIOS. They didn't put this kind of goal. They considered only like installed. How it was installed doesn't matter. So the details, the goal actually, just to repeat again, we demonstrate that VMware can be implemented on commonly commodity hardware and can be used to implement a wide range of malicious services. We show that once installed, VMware is difficult to detect or remove. We implement proof of concept VMware on 2 platforms. Finally, we will discuss how to detect and defend against the threat posed by VMware, and we implemented a defense strategy suitable for protection system against the threat. Okay, it's nice, but I would like to point here that this kind of experiments of creating ultimate weapon is really dangerous because it's not clear if there is really defense against it. Their research was based on the concept that there is already installed as an operating system on a computer, and somehow loaded malicious component is actually moving OS 1 level up and replaces OS, which is like being host OS or OS without virtualization, replacing by itself. Actually, it poses itself between system BIOS and OS. So it starts right after system BIOS hardware initialization and testing, and then when it starts actually the OS. Also, they tried to research different aspects surround this platform. They not only tried to implement this kind of malicious hypervisor VMware in their terms, but they also has a goal of setting up additional malicious software, which would be absolutely hidden from the host OS and wouldn't be identified at all. And it would be running under control of VMware as well. Sorry. So here's the slide which represents the concept. Actually, on the left you see malicious servers which implement various malicious services like web-based or whatever. On the right, you see what's been the host, which is the host system, and bottom layer is the malicious hypervisor. Malicious services, the author of the research definitely went much further than we originally discussed as malicious hypervisor and BLH. They also introduced exploits on the top of malicious hypervisor. So that is really, really threatening, because not only one layer is replaced, but also extra malicious components are added. They faced the problem as how to defend their child, which is a VM bearer, and they implemented a sort of defense which actually prevented from any component loading before VMBR. Those two components being handling reboots and emulations of system shutdown, because the only one time when they see their VMware could be affected is reboot or shutdown process. So they did also evaluation of the implementation, as any researchers, and by the way, as in Russian case, Russian scientists also evaluated command execution time. So in Michigan University, for this research, they also did very similar things, but they estimated various system running parameters. However, for our research, it's already outdated, unfortunately, because they used not hardware virtualization components. They used just original systems without hardware virtualization support, creating a virtual component, actually just writing it down from the scratch. Very interesting topic is how to defend, because they created ultimate weapon, but how to defend against? Okay, so they split on two methods. One is below VMware, the other one is above. Shortly, we don't understand how any software could run below VMware, because their VMware actually controls boot process. Trying to insert something during this process is not possible. According to their case and their goal, it's really not possible. Okay. The second thought we had, if it's really already done in malicious software which could block any other booting rather than from hard drive, yes. We found some posts on internet which says, I got a malicious software which blocked completely everything but BIOS, any booting device, but only the hard drive. So basically, below software defense doesn't work. How to identify on above? They implemented named secure boot. Yes, it's discussable. So we are not sure it will work because of the same problem that VMware exists actually right after the BIOS and can control any boot process. Trying to boot from any device and trying to put anything will be blocked. So that's what we discussed. And case number 2 conclusion. We think that design and implementation of virtual machine-based rootkit, implementation of malware utilizing VMware features, exploitation of VMware, implementation on 2 platforms, detection and defense against VMware. That's all the goals. Okay, there are 4 goals, and we briefly discussed it. So, but when you check our presentation, and also I would encourage you to read both articles, both research papers, this one and next one, so you would get like complete information. So our opinion. We don't share authors' pessimism over VMware deadly capability and optimism over detection and defeat. Russian Ghost case number 1 perfectly correlates with VMware concept and goes further by exploiting BMC capability to run malicious hypervisor on the lowest level possible. We believe that such hypervisor could even run before system BIOS, thus virtualizing it and its functions. So basically, as we see, before Russian case, it was designed and proved and tested and code existed. Okay, so basically, Russian ghost is not like a ghost. It's also a code. So our opinion is that, by our opinion, there are 2 main results: the proof of concept and the code of VMware. The research has been done before IE Symposium, May 2006. Considering that the research described in Russian Ghost case number 1 began in 2007 or later, there is complete time correlation. The concept and the code could be used to move VMware to the next level, BMC BIOS-based MBLH. So VMware, as we already discussed, it's actually memory-based. How it's loaded, others don't discuss. However, Russian case, it's already an advanced system. This sort of VMware, actually now MBLH, so it's a malicious biased level hypervisor, is already embedded in BMC and can be loaded. So we decided to figure out what actually we got out of those 2 cases. Okay, whether it's easy to deploy or to distribute the threat. Okay, so how actually it's dangerous. By our opinion, we will summarize. By our opinion is that it's not, we would say, worldwide dangerous, because it's not easy to embed MBLH in BMC BIOS. We strongly believe that Intel is not involved in that stuff, and it's somehow done after Intel signs the code and QA the code. And more likely, such operation is done, we would say, manually, somewhere even outside of a factory which could assemble boards in China. So it's malicious but manual activity which cannot really produce a lot of such boards. So we see only the possibility that such boards are produced by an entity which will or is targeting or was targeting specific vendors. Okay, so who actually got those altered boards? So as we saw, our case conclusion is, so far, based on what we already know by the cases, we don't expect worldwide distribution infected computer because of high complexity of BMC BIOS alteration process. Concerning uploading VMware in a computer system RAM, case number 2 research did not really consider options. So we don't see any real distribution by somehow uploading from a CD or from flash RAM or whatever VMBR in a computer BIOS. So it's like maybe some is going to do this kind of malicious activity, but we don't think so. It's not a way to distribute malware. Oops, sorry. So case number 3. Now we are going to the most recent case, which actually discusses the research which is done again in Michigan University, and which says eliminating the security issues surrounding light up server management. Actually, it's not about Hewlett-Packard lights up, but it's actually about vulnerability in IPMI and IPMI only. This case doesn't actually consider BMC loaded malware as real case. They mention, but they don't really consider at all. So they consider in general. So the paper examines the security implications of the intelligent platform management interface, which is implemented on server motherboards using an embedded baseboard management controller as a key component. We analyze a major OEM IPMI implementation and discover that it's riddled with the textbook vulnerabilities, some of which would allow a remote attacker to gain root access to BMC. Using data from internet-wide scan, we found there are at least 100,000 IPMI-enabled servers running on publicly accessible IP addresses, okay, contrary to the recommended best practice. So their case actually was concentrating on IPMI vulnerabilities and research on how many actually those servers could be deployed on internet. IPMI security risk. As known, all known BMC OS use Linux OS, which has many required security updates. IPMI software carries similar threats like BIOS and is likely easier to develop, since many BMC run a standard operating system, which is actually Linux. BMC malware would also likely be easier to install remotely due to IPMI substantial network-facing attack surfaces. So they discuss attack surface, and they found that IPMI implementation has a lot of open ports, which definitely could be exploited over a general vulnerabilities that they found. Authentication risks, yes, they consider that it's very likely in mass deployment of services use same password or simple password or whatever, which actually affects authentication. They considered various attack scenarios because that was their goal. So it was first subverting the host system, or BMC spyware against host OS, persistent attack from BMC, attacking BMC from the host system, IPMI botnets. Okay? And while there are actually 5 scenarios, a lot actually, and as we see that 4 or 5 scenarios tightly correlate with the case number 1, claim that malicious hypervisor has been embedded in BMC firmware. So BMC is here, and this research points BMC as a center point and weak point. They don't consider a virtual component embedded in BMC. However, they always consider vulnerabilities and utilization of BMC capabilities to control entire system. in analytics attacks and network measurements, they do different research. And actually, the most important for us, as we see, was that they actually used Supermicro production models. And they figured out that firmware having vulnerabilities actually applicable to 135 Supermicro servers. It's a lot. And plus, they used data available on the internet of internet-wide scan, which been identifying use certificates. So they extracted information from certificates, and they identified that around 105,000 servers of major manufacturers, Dell, Supermicro, and HP, connected to internet and likely having vulnerabilities. Why likely having? Because they found vulnerabilities, a lot of vulnerabilities in Supermicro IPMI implementation, and they do believe that same vulnerabilities exist in other models. And actually, how often, say, server administrators update BIOS and firmware? I do believe they update server software, but it's in really rare cases they update BIOSes. But HP, for instance, issues sometimes 5 security updates in a day for various software. How many would be applied to? I really doubt. So this research conclusion. Since VMware operates independently of the host system and CPU, cleverly written hardware, malware running there could potentially reside undetected indefinitely. Unfortunately, due to the close nature of BMC firmware, server operators have few avenues to defend themselves without vendor assistance. That's very interesting. That's a really strong point, that almost there is no defense. So if a malware, we don't say now it's malicious hypervisor, even worse, yeah? But any malware, it's not easy to detect in BMC while embedded. And without vendor assistance, but we've seen that IPMI is full of vulnerabilities. So without vendor assistance, it's definitely not possible to define or identify it. We uncovered a wide range of vulnerabilities and demonstrated 2 working attacks that allows us to gain root shell access. By the way, now it's more like bash. Those problems pose an immediate threat to many systems in the field. We found over 40,000 devices similar to one we analyzed visible on public IP addresses. 40,000 is Supermicro servers. In the long run, securing the remote management system calls for a defense in-depth approach. Vendors need to apply careful security engineering practice, minimize attack surfaces, and help users ensure that their systems are appropriately locked down, isolated from public network. Really, I'm not sure it could be done like isolation of a public network. Here we have our conclusion of this case. The research radically changes our preliminary conclusion in our conclusion in which we done concerning first 2 cases. And we now see that distribution of via IPMI vulnerability could be really worldwide. Because gentleman from Michigan University identified 105,000 servers. We believe it could be much more. Okay, we don't think the situation will improve in near future because of cost of PMI, BMC, securing and requiring time. Because it should be redeveloped. It should be completely different system. We see that modern trend towards cloud services would actually affect worldwide security, because each cloud service is a huge hub of computers. It's a data center which has thousands of connections to users every minute. So basically, this kind of infrastructure is really vulnerable because of IPMI interfaces, and even one infection of such software could affect the entire hub, because I would believe all those services are, all those servers inside a cloud service actually connected to one management network. So finally, going to close soon. We decided to do our own research how to catch, or we were trying to catch a hypervisor, or at least find a method to. So we decided will be used 100% utilization in and also in statistical net. It means instead of case one, which used just execution time, we decided to use 100% utilization. We need two options in any case, with or without MBLH, hypervisor. It's possible only if computer BIOS supports turning hardware utilization on or off. However, hardware utilization will work only if BLH is not designed to reside below system BIOS. We also consider this possibility. It's worst case scenario, but it's possible. We use supporting visualization and BIOS settings Lenovo motherbook, notebook with Linux CentOS software. The computer BIOS had two utilization related options. So we actually were able to do our research. And here we represent the table. We identified that actually runtime of one test took a bit longer. Had some variations, and been actually longer than we expected. It's around 20 minutes one run, and we found that operating systems create some deviations, so we actually needed to test 10 tests to statistically to find an average values. So in this case, in this table, second column, you see it's without enabled virtualization, and the similar numbers with 19 minutes, 50 something time. It's with enabled virtualization. So by those tables, we see that statistically we prove that there is no malicious hypervisor in our Lenovo notebook. Unfortunately, we were not able to do such research on our servers because we got the case that the motherboard from AMD, which uses AMD CPU with virtualization, doesn't allow manipulation of virtualization services. So on Lenovo notebook, we were able to shut down or enable in our servers running virtualization all the time. So basically, if there is any malicious hypervisor installed in, our method cannot be used at all. So other methods, and it seems in the case of, as we had on our servers, that's the only one which could be used, or maybe some others, but it's a matter of further research. It could be used. It could be used SIEM, Security Information Event Management System. So a lot of companies now use SIEM as a basic security service companion, and depend on this service. And that possibly is only one way how we can catch malicious hypervisors activity. So shortly, our conclusion. Basically, we see that there are three cases. First case, which seemed to be a myth, at least we don't know author, we have only a written post, which raises some questions, etc. But combining together those three cases, we see that there is real ground for. And actually, even if to forget about Russian case, Russian ghost, number one, two Michigan University research papers would be enough to prove that there is a worldwide threat for of a malicious software, which number two case, which could be distributed over IPMI vulnerabilities, which is case number three. Okay, there is no known defense against. We are basically currently defenseless. Maybe future research would find something, so I would encourage people to think about it. Maybe IPMI concept could be changed to much more secure. I don't know, but we somehow need to deal with that. So, Russian ghost VMware MBLH is dangerous as can infiltrate in millions of servers worldwide over IPMI current implementation and vulnerabilities. The hunting season is open, but be patient. We have only two perspective tools so far. Actually, one ICM, because number one, which you tried to use, it could be used, but only one case. If you can manipulate virtualization services and BIOS. In theory, we cannot identify it, but we still have a chance. There are no protection against it. Put your server in a dumpster, special thanks to IPMI. Actually, even first shipment of server from a manufacturer could already have malicious hypervisor in. Okay, so how to defend against it, I really don't know. So let's think together, and we might find a solution. But we at least can run something. If server manufacturer supports us and will certify, say, execution time of specific testing commands, then we might get to the case. Okay. And what is really discouraging is that no security standard calls for server management IPMI protection. So if you check any security standards, DSS or the United States standards or whatever, there is nothing about it. Actually, people until say 2013. Nobody was actually concerned about IPMI. And this concern is real now because we've seen it's exploitable. And we know that there is an instance which could infiltrate in systems and stay forever. So thank you very much. And if you have questions, I will be, I will be glad to answer your questions. I will be circulating around, and so just catch me and we can talk about it. Okay?
Put the references up again. Previous slide.
The what?
References. Can you go back one slide?
Yep. Those are references, of course. And the only one reference which is not, I would say, completely published is Chinese add-ons. That is Russian post. But it's translated. It's given to DeepSec, and eventually I hope it will be published. And I believe so that this presentation also will be published, so you'll get it on DeepSec.
All of the presentations will be published, so you will get them all.
So thank you very much, gentlemen, and ladies and gentlemen, thank you very much, and that's it.
Short question on...
Yes, sir. Thank you.
Short question on time
Let's stay
measurements.
together.
Short question on time measurements. I'm here. First of all, I would think if you're using the system clock of the possibly infected system, that
Yes, sir, I'll come down.
you would get, you could virtualize the time measurements too in the virtual machine.
Okay.
And the second question,
Repeat this one, okay?
I don't think, if you're measuring times of instructions, then I would expect, if I would be the author of the virtual machine of the that you are going to search, I would virtualize time too. So your time measurements, when done with the system clock of the infected system, won't show anything. And the second remark, I would not expect real-time floating point calculations to be affected, but I think you would have to test virtual machine instructions for virtualization, because if these have to be virtualized in software by the virtual machine that is already installed, these timings of these instructions would be affected by the underlying virtual machine.
Yeah, you know, it's pretty difficult to answer, because, you know, first of all, what you've seen, like in Russian case presentation, I don't have comments, because that's somebody's, okay? I don't even know his name, his age, where he lives, and I know only the nationality, okay? And by the way, I think so this guy could be tracked, because he actually identified him as working for Craftway company. If company wants to comment on such person, it could be disclosed. Okay. The only thing I think is possible concerning execution time measurements is running on 100 utilization of resources, of research. CPU is maybe the best way, 100%. Because in this case, hypervisor has to reserve certain time for itself. So CPU executes the main program, and also it should be a piece for hypervisor, because it should control. So it's an addition. If not 100 CPU, just don't know how much it is. When at 100, yes, it should be something. That's how we try to identify it.
Okay, thanks again. And let's go into the lunch break.
Thank you.